September 15th, 2017. Mark that date in your mind, because what happened on that day, and what we are only now beginning to understand about it, may be the most significant revelation in the history of human space exploration. On that morning, a spacecraft named Cassini, after 20 years of service and 13 extraordinary years orbiting Saturn, was deliberately sent to its death. NASA called it the grand finale. Scientists called it a controlled deorbit. The world called it a goodbye. Cassini plunged into Saturn's churning atmosphere and burned. Its final signal reached Earth at 7:55 a.m. Eastern Time. Mission controllers in Pasadena wept. Then they filed their reports, archived the data, closed the folders, and moved on. They thought the story was over. They were wrong. Because buried inside Cassini's final transmissions, in the very last frames of imagery the probe ever captured, something was hiding. Something that had no business being there. Something that no human analyst, no standard processing tool, and no existing piece of software could see. Not in 2017, not even in 2020. Only now, with the arrival of a new generation of quantum artificial intelligence, has it been pulled out of the dark, decoded, made visible. And what researchers found has left the scientific community divided, shaken, and in several cases, completely silent. We are not talking about a smudge, a blur, a trick of light. We are talking about structured, repeating, mathematically precise patterns embedded across Cassini's last known images. Patterns that follow rules, patterns that carry meaning, patterns that, by every statistical measure available, cannot be explained as natural phenomena. Stay with us until the very end of this video, because what you are about to witness may be the closest humanity has ever come to proof that we are not alone in this universe. What Cassini gave us and what it left behind. To understand why this discovery matters so deeply, you first have to understand what Cassini actually was. Launched in October 1997, Cassini was a joint mission between NASA, the European Space Agency, and the Italian Space Agency. It carried 12 scientific instruments and a probe called Huygens, designed to land on Titan, Saturn's largest moon. The entire spacecraft weighed more than 6 tons. It was, at the time, one of the most ambitious deep space missions ever attempted, and it delivered beyond anyone's wildest expectations. Cassini revealed the towering hexagonal storm at Saturn's North Pole, a structure so geometrically precise it has baffled scientists for decades. It discovered active geysers of water ice erupting from the surface of Enceladus, raising the extraordinary possibility of a liquid ocean beneath that moon's frozen shell. It watched Titan's methane lakes shift with the seasons. It mapped Saturn's magnetic field. It flew between the planet and its rings, a region never explored before, and sent back imagery of breathtaking resolution. In short, Cassini rewrote textbooks. But even in the flood of celebration, a few voices were quietly raising questions. Among the thousands of images Cassini transmitted in its final weeks, certain anomalies kept appearing, slight distortions in cloud formations that didn't track with atmospheric models, faint geometric echoes in the ring imagery that looked almost too clean, repeating pixel-level structures in the deep atmosphere shots that a handful of analysts flagged as possible sensor artifacts. Possible. That was the word everyone used. Possible sensor artifacts. Because without a better explanation, without a better tool, that was the safest conclusion. The data was archived. The anomalies were footnoted. And for years, nearly 8 years, those images sat in digital silence, waiting for someone or something smart enough to ask the right question. The machine that saw what we could not. In early 2025, a private astrophysics research consortium based in Western Europe announced the completion of a quantum-assisted imaging analysis system. The project had been in development for nearly 4 years, built specifically to do one thing: extract hidden layers of data from astronomical imagery that conventional processing methods had previously missed. The concept was not science fiction. It was a logical extension of something researchers had been working toward for a long time. Standard image processing works by reading what is visible: light values, contrast, color data. But quantum AI systems can go deeper. They analyze probability distributions within pixel data, detect sub-visual structures embedded in noise, and cross-reference patterns across multiple image frames simultaneously. Think of it like this. A standard computer looks at a photograph and tells you what it sees. A quantum AI looks at the same photograph and tells you what is hiding between the pixels. The consortium fed Cassini's final image archive into the system as part of a calibration exercise. The goal was simple: sharpen the images, reduce noise, extract cleaner atmospheric data. Routine work. No expectations beyond marginal resolution improvement. What came back was not routine. Within hours of the first processing run, the AI flagged something. A pattern, faint but present, repeating across multiple image frames in Cassini's final transmission sequence. The researchers assumed it was an algorithmic error, a hallucination generated by the system finding patterns in random noise. That happens. It is a known issue with powerful AI models. You tell them to find structure. Sometimes they invent it. So they ran the test again. Different parameters. Different images from earlier in the mission. The pattern appeared again. They isolated the specific frames, ran them through a secondary analysis system, completely independent of the first. Different architecture, different training data, different processing logic, same pattern. At that point, the room went quiet, because there is a word for when two completely separate systems find the same thing in the same data. That word is not coincidence. That word is signal. What the AI had found was not a smear or a blur, or an artifact. It was a shape, symmetrical, precise, present in the final images at increasing clarity as Cassini descended closer to Saturn's surface, a form that grew more defined the deeper the spacecraft fell, as if something had been waiting in the clouds and was moving closer as Cassini approached. And then, in the very last frame before Cassini's instruments went dark, the pattern vanished, gone, as if it had simply stepped back into the noise, as if it had seen what it needed to see. The language hidden inside the light. A shape alone would have been remarkable. What made it extraordinary was what the shape contained. As the quantum AI continued processing the surrounding image data, the atmospheric layers, the ring structures, the cloud formations captured in those final transmission frames, it began identifying something embedded within the visual information itself, not in the shapes, in the numbers underneath the shapes, numerical sequences, encoded within the pixel arrangement patterns of the images. And these sequences were not random. The first sequences identified were prime numbers: 2, 3, 5, 7, 11, 13, progressing in perfect order, distributed across separate image files captured at different timestamps and different camera angles. The probability of prime number sequences appearing naturally in this configuration across unrelated frames in an environment as chaotic as a gas giant's atmosphere is, according to the statistical analysis conducted by the consortium, effectively zero. But it did not stop there. Embedded deeper within the data were Fibonacci spiral ratios. The golden ratio, phi, approximately 1.618, appearing repeatedly in the spatial relationships between key points in the detected pattern. Mathematical constants that appear throughout nature here on Earth, but always as emergent properties of growth and physics, never as a deliberate sequence. Never arranged with this kind of systematic precision. Researchers who reviewed the preliminary findings drew an immediate and unavoidable comparison. When NASA launched the Voyager spacecraft in 1977, they included the famous Golden Record, a copper disk encoded with sounds, images, and mathematical concepts designed to communicate the existence of intelligent life to any civilization that might one day find it. The reasoning behind that record was simple. Mathematics is a universal language. Prime numbers, geometric ratios, physical constants. These are things any sufficiently intelligent civilization would recognize, regardless of what language they speak or what planet they come from. The patterns now extracted from Cassini's final images followed that exact same logic. This was not background noise. This was not atmospheric physics. This was a structured communication built from the only vocabulary that crosses every known boundary of intelligence. Humanity sent the Golden Record as a message to the cosmos. It appears that something may have sent one back, and Cassini, unknowingly, was the one who received it. Saturn was always the strange one. None of this would feel as significant as it does if Saturn were a normal planet. But here is the thing that scientists have known for decades and never quite been able to explain. Saturn is not normal. Start with the energy. Every planet in our solar system that is farther from the Sun than Earth receives less solar radiation and radiates less energy. It is simple physics. But Saturn emits nearly twice as much heat as it receives from the Sun. That excess energy has to come from somewhere. The standard explanation involves gradual gravitational compression of the planet's interior, helium rain falling through hydrogen. It is a reasonable theory, but it has never fully accounted for the scale of the discrepancy. Something is generating energy inside Saturn that we have not definitively identified. Then there is the magnetic field. Every planet with a significant magnetic field, Earth, Jupiter, Uranus, Neptune, has one that is tilted relative to its rotational axis. The tilt varies, but it exists. Saturn's magnetic field is different. It is almost perfectly aligned with the planet's rotation. Mathematically, this should not be possible. A perfectly aligned planetary magnetic field contradicts current models of how magnetic fields are generated in gas giants. It is an anomaly that has sat in the scientific literature for years without resolution. And then, of course, there is the hexagon. Saturn's north pole is home to a persistent hexagonal storm system, a jet stream locked in a six-sided shape roughly the width of two Earths. It has been present in every observation since Voyager photographed it in the 1980s. It does not drift. It does not degrade. It rotates with mathematical precision. Attempts to replicate it in laboratory fluid dynamics have produced hexagonal shapes under specific conditions, but never with the stability, the scale, or the longevity of Saturn's. Scientists have studied it for 40 years and still cannot fully explain it. Now, with the decoded data from Cassini's final images mapped against Saturn's surface coordinates, something new has emerged. The mathematical sequences extracted by the quantum AI do not appear randomly across the planet's face. They cluster. They concentrate at specific latitudes, and those latitudes correspond, with a precision that has left researchers quietly stunned, to known magnetic anomaly zones, the places where Saturn's magnetic field behaves most strangely, the places where our instruments have historically struggled most to get clean readings. It is as if whatever encoded that message into Cassini's final frames knew exactly which regions of Saturn our science understood the least, and chose those regions deliberately, chose the blind spots. The world of science holds its breath. When word of the consortium's preliminary findings began to circulate within the astrophysics community, the reaction was exactly what you would expect from a community built on skepticism and precision. Immediate, fierce debate. The first wave of criticism came fast. Pattern recognition in noisy data is a well-documented failure mode for artificial intelligence. Feed any sufficiently powerful system enough data and enough training to find structure, and it will find structure, even where none exists. The human brain does the same thing. We see faces in clouds, animals in stars, intention in randomness. It is called pareidolia, and AI systems are not immune to their own version of it. These were fair objections. They were taken seriously. The consortium addressed them directly. What silenced the loudest skeptics was not the shape, it was the prediction. After the AI had processed the first cluster of Cassini's final images and identified the initial patterns, the research team did something unusual. They asked the system to predict where the next pattern occurrence would appear before they fed it the next batch of unprocessed data. The AI generated a specific prediction, a precise location within the upcoming image frames, a predicted structure. When the new data was processed, the pattern appeared almost exactly where the AI said it would. They ran this test multiple times. Different image clusters, different prediction windows. Each time, the AI demonstrated a statistically significant ability to anticipate the structure before seeing it. Not perfect accuracy, but far beyond what chance would allow. This is a critical distinction. Random noise does not have predictable structure. Atmospheric chaos does not produce anticipatable patterns. The only things that generate results like this, where a model trained on partial data can successfully predict what comes next, are things that follow rules, things that have logic, things that were designed. One physicist who reviewed the preliminary data and agreed to speak on background described it this way: "If this is natural, it is the most improbable natural phenomenon ever documented in planetary science. If it is not natural, then we have to ask a question that most of us have spent our entire careers deliberately avoiding." He did not finish the sentence. He did not need to. The frame that does not exist. Everything described so far is extraordinary. But there is one detail in this story that moves it from extraordinary to genuinely chilling. According to Cassini's mission logs, the probe was programmed to execute a rapid burst image capture sequence in its final descent phase, a last gasp of data collection before the spacecraft was consumed by Saturn's atmosphere. The sequence was designed to produce 12 distinct image frames. 12 frames were transmitted. Only 11 exist. This is not a transmission error. The raw telemetry data confirms that all 12 packets were sent. The signal integrity on 11 of them was nominal. They decoded cleanly and became the images researchers have been analyzing. The 12th packet arrived. The data was received. But when engineers attempted to decode it, the content was corrupted beyond any recovery method they attempted with standard tools. Not damaged in the way a signal degrades over distance, not the expected kind of noise. It was scrambled, structurally scrambled, in a way that did not match any known form of signal degradation. When the quantum AI was tasked with attempting to recover the content of that 12th packet, it was able to identify the data structure, confirming that genuine image data had been encoded but could not produce a coherent image. What it returned instead were fragments, edges of something, geometry without context, structure without clarity. And then something strange happened during the AI's attempted recovery process. The system flagged the corruption itself as non-random. In its analysis output, the AI noted that the scrambling pattern applied to the 12th packet did not resemble standard data degradation. Standard degradation is entropic. It introduces noise in ways that follow predictable statistical distributions. The corruption on this packet was different. It had a structure, a consistency, as if the scrambling had been applied deliberately, following rules of its own, as if the image had been locked. There are engineers who will tell you this is impossible, that a Saturn probe cannot have its data scrambled by an external source mid-transmission. And they are almost certainly right, which leaves only the other explanation, that the corruption was already present when Cassini captured the image, that whatever was in frame 12 was encoded in a way that our current instruments cannot read, not lost, not damaged, hidden, and whatever it was important enough, or dangerous enough, that it was not meant to be seen by anyone who did not already know how to look. The silence that followed. In the weeks following the consortium's internal circulation of its findings, something happened that many observers found almost as unsettling as the discovery itself. Everything went quiet. The consortium's public-facing website, which had previously hosted research summaries and team profiles, was quietly taken down. In its place, a generic holding page. No announcement, no explanation. Several scientists who had been in early contact with the consortium and had spoken enthusiastically about the preliminary findings to science journalists suddenly became unavailable. Emails went unanswered. One researcher, reached by phone, said only that he was no longer in a position to comment and ended the call. Two independent research groups that had applied for access to the raw decoded data to conduct their own verification analysis reported that their requests were denied. No reason given. Funding for at least one academic team that had been publicly preparing a peer review response was, according to sources within that institution, abruptly withdrawn without explanation. There has been no official statement from NASA on the decoded images, no acknowledgement from any space agency in any country, no mention in any official government scientific briefing. The absence of a response is itself a kind of response, and this is where interpretations diverge sharply. Some researchers argue that the silence reflects institutional caution, that findings this significant require extraordinary verification before any public statement is made, and that the process is simply ongoing. That is a reasonable position. Extraordinary claims demand extraordinary evidence, and rushing to announce contact with non-human intelligence without rigorous, multi-layered confirmation would be scientifically irresponsible. Others point out that institutional caution does not typically involve shutting down websites, pulling funding, and refusing to speak to journalists. Caution looks like slow communication. This looks like something else. Whatever the reason for the silence, this much is clear. Something was found, something was decoded, and the people most directly involved in that discovery are no longer talking about it. The question is not whether they found something. The question is what they found that made them stop speaking. What this means for all of us. Step back from the specific details for a moment, from the decoded images, the mathematical sequences, the missing frame, the locked data. Step back and ask the broader question. What does this mean? If the findings hold, if the patterns are real, if the sequences are intentional, If Cassini genuinely recorded something that does not have a natural explanation, then the implications ripple outward in every direction simultaneously. It means that within our own solar system, within the orbit of a planet we have been observing with telescopes for 4 centuries, there is or was a presence of some kind that we have never formally identified. It means that this presence was not passive. It left a mark, a structured, deliberate mark, in a place and in a form that could only be found by a civilization that had developed a specific kind of tool at a specific moment in its technological evolution. As if the message was designed to be a test, as if it was built to be invisible until we were ready. Think about what that implies about timing. Cassini's mission ended in 2017. The quantum AI capable of decoding the data arrived in 2025, an 8-year gap. And the message, if it is a message, was structured in such a way that it would have been meaningless noise to every tool we had before that threshold. How long has it been there? How many times has something flown past Saturn and recorded that presence without ever knowing? How many images sit in archives around the world, on other missions, at other planets, carrying patterns we cannot yet read because we have not yet built the instrument capable of reading them? There is another dimension to this that is harder to sit with. If something left a message for us, calibrated to our mathematical knowledge, designed to emerge at a precise moment in our development, then it knew us. It knew what we would eventually understand. It knew where we would eventually look. It had been watching our progress, tracking our trajectory, and at some point made a calculation. Soon, they will be able to read this. Leave it now. That is not a random cosmic accident. That is intent. And intent implies awareness. And awareness of our civilization, from within our own solar system, fundamentally rearranges everything we thought we understood about our place in the universe. The question that will not go away. Cassini was designed to end. Its final plunge was planned years in advance. The scientists who built it, flew it, and guided it through 20 years of deep space knew exactly what its fate would be. They sent it into Saturn's atmosphere deliberately, to prevent any risk of it accidentally contaminating the moons it had spent so long studying. It was a beautiful ending, dignified and intentional. A spacecraft consuming itself in the atmosphere of the planet it had given everything to understand. What nobody planned for, what nobody could have planned for, was what Cassini might see on its way down. Music, hold. The advancement of technology has a way of reopening doors that everyone agreed were closed. We are living in an era where machines can now find things in old data that human eyes and human instruments missed entirely. That is not speculation. It is the current state of the field. Quantum-assisted analysis, deep learning systems trained on astronomical datasets, pattern recognition tools operating at scales and sensitivities that simply did not exist a decade ago. These are real, operational technologies producing real, documented results in laboratories around the world right now. What Cassini captured in those final frames was always there. It was in the data from the moment the images were transmitted. It waited, patiently, perfectly preserved, in archived storage for 8 years. It did not change. It did not degrade. It was exactly where it had been left, waiting for a mind capable of reading it. We became that mind in 2025. And now we have to live with what that means. Because here is the question at the center of all of this, the one that no amount of scientific caution or institutional silence can make disappear. If something intelligent enough to encode a mathematical message into the visual noise of a gas giant's atmosphere, sophisticated enough to calibrate that message to a civilization it was watching develop, and patient enough to wait decades for us to evolve the tools needed to receive it. If something like that exists, or existed, within our own solar system, then it was never waiting passively. It was watching. It has always been watching. And the fact that Cassini captured its presence in those final moments, that the last thing this spacecraft saw before it ceased to exist was something ancient and aware looking back, is either the greatest discovery in the history of human civilization or the most profound warning we have ever received. We do not yet know which one it is, but the message has been received, and we cannot unreceive it.